Morning. I come from the Institute of Marine Science from Barcelona, and I will present work that we've been doing for 20 years now, although I jumped on 10 years ago only. But it's about the jellyfish trend in the Catalan coast. So we know that jellyfish are increasing in some parts of the world, but in Spain, in Catalonia, that it's located in the Mediterranean northwestern basin. We've been monitoring jellyfish presence since almost 20 years, using mostly a citizen science approach. So in 2007, we started to work in the creation of a jellyfish observation network, along with the Institute of Marine Science, also with the involvement of the Catalonian government, with the Catalan Water Agency, the Civil Protection, and almost 70 coastal municipalities. And also with the involvement of the rescue services, mainly Red Cross and Proactiva. So they monitored more than 300 beaches, and this included more than 200 volunteers. I say volunteers because although the lifeguards are paid for their job, at the beginning, the data collection about jellyfish presence was completely volunteer as an extra work of as an extra of their work. So the objective was to start building a long-term data set to see or evaluate the trends of this jellyfish in the coast. The methodology it was based in the collection of the data of jellyfish presence and absence, in a daily basis, mainly during summer, that it's when we have the lifeguards the whole day during the whole season at the beach. Although we still have data from other citizen science platforms throughout the year, but the only data that has this kind of quality is the one that is obtained by this jellyfish observation network, because they follow a standard protocol of the data collection, and they check the status of the beach 3 times a day, morning, midday, and in the afternoon. So it's also important that the rescue services, they receive the training in order to know exactly how to identify, well, exactly, we know what I mean. Try to identify as well as possible the species that is present, and also to be updated with the stinging protocols. So they also receive the identification guides that complement this, the information to ensure the data quality. And we validated the information daily. This is important because this information was also published in a daily basis in the official websites like Civil Protection. And this is necessary to prevent unnecessary alarms, because if there is a mistake with the species that they are reporting, then this can create an alarm or not. So we needed to validate this information. And in case there was a mistake, it was changed in real time. So when we got more or less this database that we are still working on, and we'll keep on doing it, we decided to analyze the jellyfish presence index, taking into consideration the jellyfish presence over the total jellyfish reports, that mean the presence and the absence. And for the purpose of this presentation, as these are the preliminary results, we only considered the presence, but not the abundances or the bloom information that we are going to analyze. So the data analysis, for the data analysis, we used the spatio-temporal gammas model, including the autocorrelation to eliminate the temporal correlation. And then we got this model that after that, we used the variogram to check the spatial correlation. And then we choose the best model that was best suited for taking into consideration the species and the season, because we did it considering the 4 seasons. So in the case of Rhizostoma pulmo, we worked with the winter model, because as we are seeing right now in the last years, it's the one that mostly explains what we are seeing in summer because of the strovulation of the species. It was usually occurring at the beginning of the spring, but then we are seeing that as the winter is going warmer, then they are strovulating before that. And then in the case of Pelagia, we worked with the summer model because we were analyzing the stranded or the arrival of Pelagia to the coast, not what is happening in the reproduction period that occurs in open sea and not in the coastal areas. So considering the results, the first thing to mention is that Pelagia noctiluca and Rhizostoma pulmo are the most common species in the Catalan coast, but Belela, that is usually a spring species, we are seeing Belela even in summer because they remain in the coastal areas for longer period. And Cotyloryza tuberculata, that it was years ago, usually appears at the end of summer and beginning of autumn. Now we are seeing in the last 4 years Cotyloryza even from June on, so the whole summer season. So before I continue, I want to add here that it's necessary to take into account that the Mediterranean is warming 3 times faster, in a faster rate than the world's average. So this is leading to impacts of these warming conditions to a lot of species like other cnidarians like corals. And we are watching these mass mortality events, for example, in Paramuricea clavata, in a lot of parts of the Mediterranean. But what we are seeing is that jellyfish, maybe they are thriving with these conditions. So when analyzing all the species together without separating among species, we can see that there is a growing trend, although not exponentially, but in the last 20 years, we can see that there is a growing trend of this jellyfish presence index. And if we look at the annual mean temperature in the study area, and we look at the figure, we can see that as the sea surface temperature increase, we are also having this jellyfish presence index higher. But these results as preliminary analysis, they indicate that the mainly 4 environmental variables that were significant with this jellyfish presence index were the sea surface temperature, salinity, wind direction, and current direction. But depending on the species, these are more or less relevant because we have a coastal species and an open sea a species that is Pelagia. So we analyzed them separately because what we saw is that Rhizostoma that was common in the central area of Catalonia now is expanding to the north, and the other way around, Pelagia that was common in the north is expanding to the Barcelona area. So in the case of Rhizostoma, what we can see in the model is that the mean sea surface temperature in winter, as it gets warmer, we can see a higher jellyfish presence index. So this is probably answering that we are having more strovulation in winter season, and that's why we are seeing these adults in the summer season in a higher trend. But also the salinity is affecting the presence of Rhizostoma because we see that precisely in winter season, there is now less rainfall, so we are having higher salinity in these coastal areas. So probably this is leading to more strovulation, and even it's leading to the expansion of Rhizostoma to the northern area of Girona, the northern province of Catalonia. When we go into the case of Pelagia, the most important variables analyzed for this work were the wind and the current direction. We can see that Okay, that we analyzed the three areas of Catalonia. In the north, we have Girona. Then we have Barcelona in the middle and Tarragona in the south. Although we are not considering the data of Tarragona because we're still missing some data, and because we haven't seen yet any change in Pelagia's presence. But in the north, in the north, we can see that the wind is in some way bringing Pelagia to the area, and the change that we see in Barcelona is that maybe the wind is pushing from open sea, is pushing Pelagia to the coastal area. When we look at the current direction, we see that the current is making the action of dispersion. So while they are pushed to the coastal area, the current is helping them to disperse along the coastal zone. What happens here is that the Catalan front, that is usually works as a strong barrier between the open sea species and the coastal species because it doesn't let them in. This Catalan front is going weak. It's going weaker because of the climate, the new conditions, the climate change conditions. We are having less rainfall in winters, therefore less runoff of water in coastal areas and a higher salinity. So this is helping for this front to go weaker. So it's like probably a free pathway for Pelagia to reach the coastal areas. And if the wind and current directions are helping for this push up to the coast and dispersion, so that's why we're seeing a jellyfish presence index higher in the last years. And here I have time, so I can add, if you remember the concept of Boero about the vertical migration of Pelagia, that it says that precisely in the early spring and summer season, Pelagia are coming to the surface from the canyons. So probably Pelagia is still reproducing and feeding in the canyons area. But if by this time they are up in the surface, they can be pushed and carried out. And with this no barrier, so we are getting more Pelagia in this season in the Catalan coast. So as preliminary conclusions, we can say that the environmental conditions influenced by climate change, that is the increasing sea surface temperature in the study area, the changes in the rainfall regime, and the changes in the seasonal temperature, because we are having increasingly longer summers, and also these marine heat waves, then we have better conditions just for one or more stages of the life cycle of the jellyfish. Can be the polyps, the asexual reproduction, or the sexual reproduction, or even in the case of Pelagia, just the way to reaching the coast. So consequently, we are having an increase in the jellyfish presence in this area. Of course, we are still analyzing data, and we will keep on recording this presence for making a longer database, and we will get more results during the years, I hope so. And thank you very much, Dhanyavad, and special thanks to Veronica, because she started this work, and for sure we're going to keep on doing it and registering what she started with a lot of effort when she arrived to Barcelona. So this is in her memory. Thank you.